Hi guys, this video is a network architect design, how we design our daily networks, and what are the aspects that we need to check to design the network. Anyhow, without doing any delay, let's jump onto the networking. So here my slide. It is very easy to explain, and even you can take some notes from my slide. Okay. So whenever we think about network, think always about first of all performance, redundancy, and availability. Okay. So what is the performance ratio will be on our network? What is the redundancy? What type of redundancy we are going to give to the network? What is the availability of the network? So okay, so these are the basic steps that you should need to. This should be the primary concern of any network architect. Okay, it's due to we are having mission critical networks nowadays where we want more stable networks, even though a small organization won't afford the downtime of the network. Okay, so it's always a challenge for a network architect how he or she design type of hardware that they are that going to use, and data flow, and type of protocols to run the network. Because the once you do the once a network architect do the network, the basic design, it is going to stay like at least like 3 to 4 years on the same setup. So whatever you are going to run, it should be run on top of that. So that is how the network architect is critical. Okay, so even though if you implement a new technology, it should goes on top of this network design. Okay, so let's jump onto the other slide, and here in this video we are going to learn how OS the first hop redundancy protocol going to today's agenda going to help us. Today's agenda is first hop redundancy protocols. Okay, this is not a protocol. FHRP is not a protocol. It's just like first hop redundancy protocol. It's a summary of this name. Okay, under this FHRP, we have three protocols which are HSRP, VRRP, GLBP. And here I gave the definitions of that one: hot standby routing protocol, virtual redundancy routing protocol, gateway load balancing routing protocol. Okay, so these three types of protocols goes under FHRP, which is for first hop redundancy protocol. Okay, so to better understand these protocols, you should need to know the theory about how they work and how we implement them to get the benefits of our network design. Okay, anyhow, okay, let's go to the objectives. So now in these objectives today, I'm going to teach you about design, describe the network design, describe the routing or switching issues, failure scenarios, configure the HSRP, the way how we configure the HSRP load balancing, various troubleshooting issues with HSRP, HSRP interface tracking, differences between HSRP, VRRP, and GRRP, and GLBP with configurations, and troubleshooting. Okay, so now the question comes: why we need redundancy? Okay, say this is very basic network setup. Okay, it's like you can say like very basic. Okay, but nowadays you see this setup very rarely. But it is to understand we should need to go with this one. Then later we can able to see we can able to implement what better we can do on the existing setup. Okay, so anyhow, so here, like for example, as we ask the question here, why we need redundancy? Okay, so now let's assume that this computer, like, okay, now I have three computers over here. This one, two, three PCs with three IP addresses and the default gateway. And can you check the default gateways over here? 10.1.1, 10.1.1, and 10.1.1 is the default gateway. Let's assume that they are all connected. They are on the switch in this switch. Okay, let's assume that they are going to access this server. Say let's assume this is the Cisco server, or like any file server. Okay, so now since it is a default gateway of 10.1.1.1, okay, so now this PC going to communicate via the switch, and this is the data path that I'm showing you. It is going to go via this router, and this is going to go via this router, and then this is going to go over here, and then the return path, it's going to come like this, like this, like this, and then like this. Okay, so there's a return path. So now the question comes, say let's assume that this router going to fail. Let's assume that this router going to fail. Okay, now even though we have the network setup over here, even though this router over here we got, okay, standby, okay, it's not doing any job, since our network design is, because of the gateway, okay, because our ultimate goal will be, our how our hosts are communicating. That means user traffic, how the user traffic is routing. That's our ultimate goal. Okay, all the network devices that we put in between, just to make sure that our data goes smoothly without any issues, without retransmissions. Okay, and these users got the uh, the platform where they can use the better network services. Okay, so right now, so let's assume that this router goes down. Okay, so now since they are binded, these users are binded to the gateways, to this gateway. Okay, so now this router, after the link fails, okay, still these routers trying, these computers trying to send the data to this router, but this router is down, so the data is getting choked, and then the data just come back. Okay, so to solve this issue, there is a possibility that we can do. Okay, let's change the gateway. Okay, this gateway, we can change this gateway. Okay, so now if you have like 3 computers, no problem, you can change the gateway manually. You can give the gateway of this guy, which is 2. This is 2. Okay, instead of giving 10.1.1.1, you can give 10.1.1.2. But the problem is that, let's assume that you have 100 PCs over here, 100 users over here. What will be the scenario? Like, what is the administrative task over here? Okay, and okay, let's assume that you just configured all the 100 users, it's a gateway 2, and after we fix this router, okay, this router, after we fix again, we are going to change again. Okay, so this is very hectic job for the network admins. Okay, so for this reason, we are going to take help of the redundancy protocols. Okay, so let's see how we are going to get benefits from the redundancy protocol. Okay, let's erase this guy. Okay, so now what we are going to do, okay, we are going to merge them into a virtual link. Let's assume this is a router. Okay, so we are going to assign a IP 10.1.1. Say 100. We are going to bound them to a virtual IP. Okay, where now, and then we are going to change here as a gateway as 100, as a 100. Here also the same 100, 100. Okay, so by doing this change over here, so now these all the users are transparent, whatever the changes happen over here, they don't care. Okay, because we tied them, these 2 routers, with a one virtual IP. Okay, let's understand what is virtual in the incoming slides. Okay, you will understand what is virtual IP and how we are going to achieve this task. Okay, so let's move ahead onto the different tasks. Let's delete before we leave. Okay, Okay, first hop redundancy protocol. These are like there is a debate between like I saw some debate between people like it's a layer 2 or layer 3, but you can say more over layer 3 because of it's dealing with the IP. Okay, even though they are giving the ARP request and stuff like that, they are doing the ARP they are sending the ARP request from the user, the user computers, whoever do the request. So whatever it is, I believe personally it is, these are layer 3 protocols. Okay, here you need to take these notes. One way to achieve near 100% network uptime is to use the gateway redundancy protocol. How? Ensuring that user traffic immediately recovers from the first half failures in the network and route the traffic automatically to other path without affecting the edge network configuration. Okay, so this one over here, if we go to previous slide. Okay, so what it mean over here, ensuring that the user traffic immediately recovers from the first half failure. Look, whenever a router failure, okay, whenever a router failure, it goes, the traffic automatically routed to the other path without affecting the edge network configuration, which is this configuration over here. So it's not going to affect the configuration at the edge. Okay. Okay. By sharing the IP address and the MAC address, two or more routers can act as a single virtual router. Okay. These routers become members of each other and exchange the status messages. Okay, so status message means like sending hellos, like if the router is alive, or hold time error, like you will come to know later on in the configuration. Okay, so this way they share the load or responsibilities in each of planned or unplanned device outages. Okay, so by communicating by this one, these routers become members of each other and exchange the status messages. By exchanging the status messages, they can able to share the load or responsibilities. Okay, in case of planned or unplanned device outages. Okay, host on our access layer continue to forward IP packets to a consistent IP and MAC address, and the change over the data flow is completely transparent to the access layer. So as I discussed here, that these if we implement the redundancy protocols over here, so whatever the change happen here, these users are transparent and they are independent. They don't need to do anything because of the decisions going to take all the decision going to take over here. So we are not going to care this one. So this makes users to flow their data smoothly without having any issues. Okay, so let's learn about what is uh, a protocol one by one. Okay, so let's start with HSRP, which is hot standby router protocol, which is HSRP. Okay, HSRP basically come with version 1 and version 2. Okay, so these are the cliff notes for you if you want to attend an interview, or if you want to make yourself like a proper, like what exactly, like bullet points. So these are the bullet points that I researched online. Okay, I got it for you. HSRP is a Cisco proprietary. It's a UDP protocol. UDP, it works on UDP port 1985. Okay, and it uses a multicast 224.0.0.102. And then the virtual MAC address of this is the virtual MAC address used by sorry. So this is the first hop redundancy protocol. It's also Cisco proprietary UDP port 1985 multicast 224.0.0.2. So this is the virtual MAC address, which is 00000C07ACXX. Okay, these are the group numbers 0 to 255. Okay, preemption by default disabled but can be enabled. Okay, just you need to give command preemption. That's it. HSRP priority ranges from 0 to 255. Default is 100. Highest preferred. Default hello timers 3 seconds. Every 3 seconds, the the active router send they exchange the hello timers every 3 seconds. Okay, hold down timer is 10 seconds. Okay, active router election. The highest priority wins. If the priority same, then the highest IP wins a tie. Okay, say for example, like if this and this got the same priority, this router and this router got the same priority. So whatever the interface, like where under whichever the interface we configure the configuration of the HSRP, it says that this is like 192.168.100.1. Okay, in this scenario it is 192.168.100.1. This router, oh sorry, this router is like, if we configure this side or if you configure this side, 10.1.1.1 is router A, 10.1.1.2 is a router B. Then what it will do, it will take this as a, if this priority and this priority is the same by default 100 and 100, and now this router 10.1.1.2 router become active because of the highest IP address. Okay, so default hello timers are 3 seconds, hold down timer is 10 seconds. Okay, if it won't receive the timer for 3 the 10 hello timers for 3 seconds, then it will hold for 10. Okay, if it still won't receive, then the preempt come into picture. Okay, active router election we done already. Support clear text authentication. The router priority decremented by the associated value, default 10 if the tracker interface fails. This one I will explain you when we use this scenario, track scenario. This is very helpful also. Okay, the router modes over here, or in HSRP version 1 is active, standby, and the listening. Okay, you can have, you need to have, for every active there should be one standby. For every active router there should be one standby router, and there are many listen, like up to 6 up to 8 listens will be there, depending on the iOS configuration. And some of, if you are using the high-end switches, if you are having the soup, then you can have up to 16 also in the HSRP configuration. Okay, okay, before we move, let me tell you why we are saying this one XX and why we are getting this value. Okay, so this is default value. From here till here is a default value. So XX means every hexadecimal is 4 bits. 4 bits. Every hexadecimal character is 4 bits. So you have here 2 bits. 2 plus 4 plus 4 equal to 4 plus 4 equal to 8 bits. Okay, 8 bits. So now how you got this number over here, 0 to 255? It is 2 to the power of 8 equal to 256. Okay, that's the reason you are using 0 to 255. Okay, so this is the HSRP version 1. Let's jump onto the HSRP version 2. Okay, almost the same. This is I believe it is the UDP protocol 1985. Okay. So HSRP, this is HSRP version 2. HSRP is a Cisco proprietary, as same as the HSRP version 1. It also uses the UDP protocol, UDP port 1985. Here the multicast is different. Multicast is 224.0.0.10. When you compare with HSRP version 1, it uses 224.0.0.2. Here it's 102. Virtual MAC address, this uses the different virtual MAC addresses, 0000, 0C, 9F, F, and 3X are there. I will explain you how it become 0 to 4095. Okay, preemption by default disabled can be enabled. Okay, it's just simple to enable the preemption. HSRP priority ranges from 0 to 255. Default is 100, higher preferred, same as HSRP 1. Same timers over here also, 3 seconds, holder timer is 10 seconds, which can be changed. Even in HSRP 1 also can be changed. Active router election, the highest priority wins. If the priority is same, then the highest IP win a tie, same as HSRP version 1. Support clear text and also MD5 authentication. Okay, this is the plus point here in HSRP version 2. The router priority decremented by the associated value, default 10, if the tracked interface fails. Okay, so the modes are same as HSRP version 1, active, standby, listen. This supports IP version 6. Okay, so the HSRP version 1, okay, this supports IP version 6. Okay, so now let's go with the configuration of HSRP, and this will help you to better understand. Okay, so in so here this is the HSRP. This will be like, if you have like this scenario, so one router will be active, other will be standby. For every active, there should be one standby router, and there will be like 6, 7, up to you. The listen depend on your iOS. You can have as many as listen, but I think limit is 60. Okay, if you have high-end series routers, switches or routers. Okay, so how you are going to configure? Both interface should be the same. Okay, almost same, except the except the priority values. Okay, so if you take one interface, under one interface, whatever the interface you are going to configure, interface FA0/0, IP address, you are going to configure the IP address. Okay, so standby version, you are going to give IP version, like you already have the IP address over here. Okay, standby version 1 or version 2, standby 1, because this is the group number over here. These are all the group numbers now. So whatever the group number you use over here, you should need to use the same group number in the other side also. Okay, so standby IP 10.1.1.1, this is the virtual IP. This is a virtual IP that we are going to use. Okay, in this example, in this like theory, this is the virtual IP over here. So we are binding the two routers using this virtual IP. That means in the other side also we are going to give standby virtual IP, the same 10.1.1.1. Okay, so timers, we can able to configure, or else if we leave it, if we don't configure, then default timers will be 3 and 10. Okay, so we can change the timers, but it's not required to change the timers. That should be fine. Okay, so this is the priority. So all the commands, remember that all the commands over here start with standby. Okay, okay, so the preempt, the priority is priority. So by default it is 100, is the default priority is 100. Okay, so you can give, if you want this router to be active, then you need to give more higher than 100. Okay, so the preempt over here, authentication MD5. Okay, if it is like HSRP2, you can have MD5 authentication. This track interface tracking value, I will explain you what is this tracking interface. And then track object decrement, we can able to decrement the value also. Okay, or else if we don't give this command, by default it decrements the 10 value of 10, it get decrement. Like if you gave, if we gave here like 110, okay, whenever the interface goes down, okay, so if by default it less the 10 by default, so it become 100. Okay, I will explain you where this is very important, and how we need to deal with this one. Okay, another, these are the show commands. So you can use show standby, only. This give you the all the output. Okay, if you want the summary, then you need to use show standby brief. Okay, so these are two commands actually. One command is show standby, the other command is show standby brief. Okay, so this command is very important, guys. Over here, this command is very important. Let me explain you right now about interface, track interface also. So standby, this why I said this command is very important. Standby one, group number, priority number like priority. Okay, preempt. Okay, preempt, delay, minimum seconds. Okay, so why I'm saying that this is very important here. So let's assume that we have, let me get this document here. This sorry, let me get this picture. This is will be better to explain you. Let me make it smaller. Let me take the snapshot of this guy. Okay, so let me take the snap. New. Okay, so let me grab it over here. Okay, why I said this is very important. Okay, let me delete this trash over here. So I said this command is very important, preempt, delay, minimum. And before we go there, let's discuss about the tracking. Okay, let's discuss about tracking. What I said about the tracking. Okay, let's use this guy only. This pen. Okay. So now think about tracking. Uh, okay, I will discuss the tracking later on. Okay, think about this router goes down. Something happened. This router goes down, and then within like within the 10 seconds, this router take over. Okay, because of the preempt. Okay, so now this router is working. Okay, so this come back again. Let's say that this here 110 is the priority value. Okay, this router got priority value default, which is 100, which is 100. Okay, so now so when this router goes down, this router takes the control. Okay, now let's assume this router come up within like a minute. This link is flapping. Okay, this link is flapping, or the router, there is some problem with the router. Okay, these problems happen with the link flaps. More problems I saw. Okay, so this link is flapping. It just go down like for fraction of seconds, like 20, 30, or 50 seconds, or 1 minute, less than 1 minute, and then it's come back. So when this router come back, okay, or when the link is come back, since the priority is 110, it is going to get the control back again because of there is preempt is there. Okay, so let's assume that this came back again, this router got the control, and then this link got a problem again. Okay, flap. Okay, so again this router takes the control. So again this router takes the control. Okay, so let's assume that this link came after 1 minute, after 2 minutes. Again this router takes the control. Okay, and then say let's assume that again this router goes down. Okay, this router takes the control again. Let's assume that this router come back again, and then control goes back. Okay, so the problem is that this user don't know what's going on, completely isolated, as we said. Okay, but the problem is that we have the problem with the data flows. Okay, so here we will get risk of data flow. It's just like there won't be any problem with the data flow. It flows, but unnecessarily we are transferring sometimes control to this router, sometimes to this router, sometimes this router. So in this case, okay, we are going to be make sure whenever the router come up, okay, we are going to give delay. Okay, don't preempt until unless that this router going to stay, like we can give like, okay, preempt for 300 seconds, which is for 5 minutes. Okay, whenever this router come up and stays without any problem till 5 minutes, okay, now you are going to get the control back to you. If it goes within this time, then nothing will happen. This router will be active, okay, and this router will have all the trouble, and this will be alone standby router, and it is trying to recover the issues. Okay, once it recover the issue and it goes the period of 300 seconds, then the router, it can ask, okay, come on, I'm okay now, give me back my control. Okay, so this is where it will be helpful, this command. Okay, let's go move on. Track interface, I will tell you, because you should need to know about internally what we are doing, so that then only you can understand the tracking interface. Okay, okay, so here there is a note in HSRP version 1, the group numbers can be any value between 0 to 255 and must be same on the both routers. Okay, as you know, so if you use the group 1 over here in the second router here and here also, you should need to use the same group. Okay, so in HSRP version 2, the group numbers can be any value between 0 to 4095 and 4095. Yeah, and must be same on the both routers. Okay, if the routers do not have preempt, okay, so here if the routers do not have preempt, okay, let's assume that you do not configure any preempt. Okay, you did not put preempt command. This is why this command here, why I'm stressing this one, because by default in HSRP, preempt is disabled, as we saw in the previous slides. So when there is no preempt, okay, when the router boots up, they got the priority, default priority of 100. This guy over here, this is 100. Okay, so first, then the others in the standby group becomes the if the router do not have preempt configured, a router that boots up, okay, a router that boots up faster than the others in the standby group becomes the active router, regardless of the configured priority or the highest IP address. Because even though this router got highest IP address, okay, even though this router got highest priority, if there is no preempt command is there, because this will forcefully take the control, but it completely depends on a priority command. Okay, or some vice versa, and priority command depends on the preempt also, because even though priority is higher, if there is no preempt, it cannot do anything. Okay, that's the reason this bullet point shows you, even though if whatever the even though if the priority is configured higher, okay, if there is no preempt command enabled, okay, if there is no preempt command given under the interface, still the router stays as it is. Okay, and whichever the router among these boots first, they become the active, and then the second one become standby and the third one become listening state. Okay, so now you understand here. Okay, let's delete this one. Let's go to the next slide. Okay, now let's talk about virtual redundancy protocol. Since we are talking about the redundancy protocols, you need to understand the glimpse of all the protocols. Then only it's better to understand the differences between them. Okay, and even though in the interviews also, it's as it says, it's open standard. VRRP uses IP protocol rather than the UDP port. Okay, which is 112. Protocol number is 112. Other hand, HSRP uses the UDP. Okay, it uses the multicast 1118. Okay, it is a multicast 1118. Okay, supports clear text authentication. Okay, so preempt, here the preempt enabled by default, unlike the HSRP. HSRP, you should need to give the command to enable the preempt. Here no need to enable, it's already by default it is enabled. Okay, virtual MAC address. Okay, so here again, because of these are two. Okay, these are two. 2 to the power of 8 equal to 256. Okay, so default hello timer is here 1 second. Backup routers learn the interval from the master. Okay, so modes master or backup over here, unlike the HSRP, which is active, standby, and listening. Here, one master and all are the backups. Default priority as it is in the HSRP. Okay, no load balancing support here, even though in the load balance in the HSRP also there is no load balance support. IP version, there is no support for IP version. So let me go back to the previous slide. Let me go back to the previous slide. So here, okay, because of this 444 12. Okay, so each hexadecimal bit equal to 4 bits. 2 to the power of 12 equal to 4096. That's the reason we got here 0 to 4095, which I specify over here. Okay, so I forgot this one, so I show you. Okay, so let's move on. Okay, after the virtual redundancy protocol, okay, here also in HSRP also there is no load balance here. Okay, you will understand when I implement the HSRP on the devices, you will understand properly. Okay, so this is the VRRP. So VRRP, one is master. So let's get my pen. One is master and others are backup. Okay, so here interface. Okay, this is the configuration of the interface. VRRP1. This is the IP address. Okay, these are the timers. If you want to change the timers, if not by default, it's 1. Okay, so VRRP 1 priority. This one no need because it's already, if you give no problem. Okay, it's already enabled, but better to give the preempt so that when we saw the output, we will know that okay, preempt is enabled on which interface and how it's enabled. VRRP supports MD5 key string. I don't think so. I think VRRP supports only the clear text. I think the clear text. I don't know. Let me. This one I'm having doubt. You please do the research. I think according to me, it's a clear text. Okay. So VRRP track 1. This also track the object and it can decrement the value. Okay. Value. I will show you. This command you will understand only when I show you the practicals. Okay. So here show VRRP is one command and show VRRP brief is second command. Okay. So we are done here. So let's move on to the GLBP. So guys, GLBP is itself is a huge protocol. Like it's a vast protocol which I need to post one more video only on GLBP. But here I just gave you the overview of the GLBP terms in the GLBP, AVF and AVG. You should need to remember this one. Okay, because in interview they might ask you, but what is the function of AVF and what is the function of AVG? Okay, you should need to know what is the AVF means and what is the AVG means. AVF, active virtual forwarder, okay, answers for the virtual router and assigns virtual MAC address to the group members. Answers for the virtual router and assigns virtual MAC addresses to the group members. That means whoever the groups, okay, it assigns the virtual MAC addresses. Okay. So now AVG, active virtual gateway. All the routers which forward traffic for the group. Okay. So that means active virtual gateway means the all the routers which forward traffic for the group. Okay, they are all binded to one virtual gateway so that they can do the load balance. But here the beauty of this protocol is we can do the load balancing here. See this one, load balancing. Okay, when you do the practical, you will know. But we are not doing the gateway load balancing protocol, but you will understand what is why the gateway load balancing protocol is different than the HSRP or VRRP. Okay, only same functions except the load balancing. Okay, this is also Cisco proprietary protocol, works similar to HSRP, VRRP, but with a true load balancing capability. All the routers in a group forward traffic simultaneously. This is the traffic forward simultaneously. Okay, this is the main important. Uses the UDP port 3222. Okay, this is the interview question. Okay, uses the multicast 224.0.0.0.102, same as the HSRP version 2. Okay, so as I said, HSRP version 1 uses dot 2 only. Okay, HSRP version 2 uses 102. GLBP also uses the 102. This common 224.224.0.0 is the common. Okay, so here is the virtual MAC. Okay, so these are the four: active virtual forwarder 1, active virtual forwarder 2, virtual forwarder 3, virtual forwarder 4. Okay, so these are the MAC addresses. This will flow the same here. Same MAC address. Okay, only the last digit will change: 01, 02, 03, 04. Okay, AVF1, AVF2, AVF3, AVF4. Okay, so this is the fact about the GLBP. Let's see if I have more slides here. Yep. So here the GLBP. So the active router, active virtual forwarder, and active virtual gateway. This router act as a active virtual gateway, which holds all the information about the members, about the members. Okay, and then at the same time, see, this router is forwarding, this router forwarding, and also this router is forwarding because of the AVF, 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 AVF. Okay, so in the previous slide we said about this IPs, yeah, this virtual MAC address. So they will take one by one MAC address from here, so that they can forward the traffic. Okay, so here the configuration here, GLBP. Only blindly you need to know when you go back here. Very simple. When you do HSRP configuration, so let me delete this. When you did the HSRP configuration, all HSRP start with standby. Okay, here. So when you did the VRRP, all the VRRP configuration start with VRRP. Okay, so when you do the GLBP, all the GLBP get hold of the same configuration. So same GLBP is the configuration will be start for the GLBP. Okay, so this is very easy. So this is the GLBP show command for the GLBP. Okay, show GLBP is the one command. Show GLBP brief is the other command. Okay, so here also the same priority timers hello and dead. Okay, redirect traffic. You should need to understand this one. Okay, this is bit different. Okay, you have more forwarder preempt, and you should need to know what exactly happened behind the scene. This one I will try to explain in the later upcoming videos. Thank you very much for watching this video, and I'm going to make this video as only theory. So the next video will be the practical. So please go ahead and have a look at the practical. Then only you will understand what I said about the theory. Okay, I just want to keep this video short rather than keeping the lengthy videos. Thank you very much, and please do leave the comments and do give a thumbs up if you like the videos. Thank you very much.